Hi everyone, I'm Doug Markant from the University of North Carolina at Charlotte. Today I'll be presenting our paper, When Do Data Visualizations Persuade? The Impact of Prior Attitudes on Learning About Correlations from Scatterplot Visualizations. Data visualizations play an increasingly vital role in science communication on all sorts of issues, including lots of societal challenges where it's important that the public has some common understanding of the scientific evidence. Some visualizations seem to speak for themselves. They seem to make an empirical pattern so clear that it can be hard to imagine that they wouldn't be convincing to another person. Like this example related to COVID-19 vaccination, showing that higher rates of vaccination across different states are strongly associated with lower rates of hospitalization. But we know from psychological research that people's existing views can exert a strong influence on how they perceive and evaluate evidence in all sorts of forms. I'm personally pro-vaccination, so maybe I only find this data compelling because it's consistent with the views that I already hold. What about for someone who doesn't share those views, like someone with an anti-vaccination attitude? Would they evaluate this evidence in the same way, potentially change their view about the effectiveness of vaccines? Or because of their existing attitude, would they evaluate this data in a different way, for example, perceiving the relationship to be weaker or more uncertain, and as a result be less likely to change their existing views? Our paper is part of an effort to answer this broader question of what kinds of data visualizations are persuasive. When do they lead to changes in beliefs and attitudes, especially among audiences for whom the data conflicts with strongly held existing views? In the study that we describe in the paper, we measured changes in beliefs about correlations after viewing scatterplot visualizations. So first, before people saw a data set for a given pair of variables, they would indicate what they thought was the most likely relationship between those variables, as indicated by this orange line. Then they'd be presented with a data visualization. And after seeing that data set, we'd again ask them to indicate what they thought was the true relationship. So a key outcome of interest that I'm going to present later is how much their belief changed from before to after seeing the data. The study was designed to answer three research questions. The first question was, how do existing attitudes affect whether or not people change their beliefs about these sorts of empirical relationships? This question is really informed by research on the psychology of persuasion, which has shown that the way that people evaluate evidence in a range of contexts is shaped by their broader attitudes about a topic. Strong attitudes can lead to biased evaluation of evidence or create resistance to belief change. For instance, a person might have a belief about a specific empirical relationship, like thinking that vaccination is associated with greater rates of mortality. The typical goal of a data visualization is to inform, to present evidence that can potentially change that belief, for example, by presenting evidence that there's a negative correlation between those variables. But thinking beyond that specific belief, people also have broader attitudes. An attitude represents more of a holistic evaluation about a topic, for example, being anti-vaccination. And importantly, these attitudes aren't just based in empirical evidence. They're also linked to personal values, social identities, and other motivational factors that influence how you see the world and which shape your beliefs. So our first research question was aimed at trying to understand this influence of existing attitudes on how people learn from data visualizations. We collected some real-world data sets that were related to two topics, COVID-19 vaccination and labor union membership. For each of these topics, before people saw any data, we first measured their overall attitude regarding that topic. They were then presented with these 6 data sets where for each one we elicited their beliefs before and after they saw the data. And finally, we again evaluated their global attitude regarding that topic. And we repeated the whole process for the other topic after. All right, so let's look at some results for this first research question. So these plots are showing the distributions of prior and posterior beliefs for each of those pairs of variables that I showed before. The prior distributions shown in pink start off relatively diffuse, with participants having a range of different beliefs about each correlation. The vertical dashed lines represent the true correlation shown by the data. And what you can see is that the posterior distributions shown in blue strongly converge toward that sample correlation. So there's evidence that people are changing their beliefs in response to the data. Now, the real question is whether the amount of belief change was affected by participants' existing attitudes about the topic. And in fact, we found that people made smaller adjustments to their beliefs when they had strong attitudes on a topic. So when people had a neutral attitude, for example, they neither supported nor opposed COVID-19 vaccination or labor union membership, then regardless of their prior belief, their posterior belief essentially matched the sample correlation that was shown by the data. They're adjusting however much they need to in order to align their belief with what the data shows. However, among people who had a strong attitude, when their prior belief differed from the sample correlation, they made smaller adjustments on average. So it's not the case that people with strong attitudes are completely ignoring the data, but their posterior belief represents more of a compromise between their prior belief and what the data suggests. Our results show that, yes, when presented with statistical evidence in the form of these scatterplot visualizations, among those people who had strong existing attitudes, they showed smaller changes in beliefs in response to the data. Our second research question concerned the role of visual representations of uncertainty in belief change. In the science communication literature, there's an outstanding question about the role of information about statistical uncertainty in persuasive communication, with some concern that it can actually undermine the persuasiveness of a message. We asked a similar question here. Does the inclusion of uncertainty representations in scatterplot visualizations lead to less belief change, and especially among those people whose prior attitudes conflict with the data? This is especially motivated by recent research showing that uncertainty representations can draw attention away from other statistical summaries like the best fit line and lead people to overrepresent the likelihood of lower probability outcomes. So our reasoning was that, especially if people have prior views that strongly conflict with the data, we expected that the inclusion of uncertainty representations may make it less likely that they would change their beliefs about a relationship. So in our task, there was also a between subjects manipulation with 3 visualization conditions. The first was the line condition, where the scatter plots were accompanied just by a correlation line. So here there's no representation of uncertainty. Then there were 2 additional conditions with visual uncertainty representations. First, the ensemble condition, where the uncertainty region showed different relationships drawn from the 95% confidence interval. And then a hypothetical outcome plot, or HOP condition, where those same draws from the 95% confidence interval were presented in an animated display. The results comparing these conditions showed that indeed there is an effect of uncertainty representations. So in the line condition with no uncertainty, there's very little effect of prior attitudes on belief change. But it's in the ensemble and the HOP conditions where we really see this effect, where people with strong attitudes on a topic made smaller adjustments to their beliefs. So for the second research question, the findings support our original prediction that uncertainty representations appear to interact with people's prior attitudes and can lead to less belief change compared to when visualizations don't have uncertainty representations. And lastly, our final research question was about whether these visualizations would change people's overall attitudes. As I showed earlier, at the end of the task, we again asked people about their overall attitude toward each topic and assessed whether there were any changes, but the basic conclusion here is that we didn't find any evidence that people's overall attitudes changed as a result of interacting with the data. All right, so I'll wrap things up with a few takeaways. First, a lot of existing work on how people judge the strength of a correlation from scatterplots has focused on bottom-up perceptual processes. For example, what kinds of visual features affect the strength of the perceived correlation? Our findings add to growing evidence for top-down influences of prior views on how people evaluate scatterplots and whether they change their beliefs about correlations in response. And crucially, we found that you have to go beyond thinking about people's belief about a specific relationship to consider their broader attitudes about a topic. So in our results, it was especially among those people with strong anti-vaccination attitudes where we found the greatest resistance to belief change. Whereas people with neutral or pro-vaccination attitudes were more willing to update their beliefs, even if their initial guess had turned out to be wrong. A second key finding is that uncertainty visualizations seem to play an important role here. So when the data conflicts with prior views, uncertainty representations may draw attention away from the correlation line, for example, or other visual features in the scatter plot, and undermine the persuasive power of a visualization. And lastly, I mentioned that we didn't really find any evidence for attitude change. So this isn't too surprising. The literature on persuasion suggests that attitude change is hard to achieve, especially with brief interventions like this one. One way to make a data visualization more persuasive more likely to change attitudes might be to encourage viewers to think more actively about the content of the message and the ways that it conflicts with their prior views and their personal experiences. So this is something that we're currently exploring in ongoing work. Thanks very much for your attention, and please check out the paper if you're interested in seeing more. Thanks.